Welcome to today's lesson on the average rate of change. The formula for the average rate of change is y2 minus y1 over x2 minus x1. And if that formula looks familiar to you, that is good because it should be familiar because that is the formula for slope. And that's because the average rate of change is essentially the slope between two given points. And the way a question will usually be asked is that it will ask you to find the average rate of change of a given function either between 2 points or over a given interval. That's actually the wording that you're going to find on the next worksheet. That's going to say find the average rate of change of the function over the given interval. And I think that worksheet also asks you to find the instantaneous rate of change, and that is going to be in another video lesson. But as an example, this is one of the examples from that worksheet. It's asking you to find the average rate of change of this function over this interval. And we know that that's the formula, so really we're trying to calculate the slope. But the slope of which 2 points? Well, really what we're going to find is the slope between the point whose x value is 2 and whose y value we're going to calculate by plugging in x is 2, or in this case t is 2. And the other point is going to have an x value or a t value of 5 over 2 and a y value or g value of what we get when we plug in 5 over 2. So that's essentially what we're doing. Notationally, I'm going to call that the slope between the points 2, comma, g of 2, because I know that 2 is my x, and g of 2 is the y value, if you remember your function notation. And the other point is going to be 5 over 2, that's the x, and g of 5 over 2 is the y. So what kind of work do I need to show? Well, algebraically, I'm going to find g of 2. So that means taking this function and plugging in 2 for all of the t values. If you want to pause and try that, now's a good time. I'm just going to show the answer. When I plug in 2 here and here, I get a value of -3. That's the y value when x is 2. Or if I'm using the right letters, the g value when t is 2. And I'm going to do the same thing for 5 over 2. If you want to pause and try it, go for it. Here, that works out to be a value of -13 over 2. So in the end, my average rate of change is just the slope between those 2 points, between this is going to be my y2, this is y1, and my 2 x values are the 2 endpoints of the interval in question. So when I plug in, I'm going to get -13 over 2 minus -3 divided by 5 over 2 minus 2, the x values at those 2 points. And when I simplify that, it works out to be -7. So what does that mean? Well, I think the best way to look at that is visually. Visually, or graphically, if we go back to this function, I could graph that, and I did, and I'll show you what it looks like. That function looks like this. So what I did was I graphed that function, and I highlighted on it the 2 points in question that we just calculated, 2, comma, -3, and 5 over 2, or 2.5, comma, -13 over 2, or -6.5. So when we're asked to find the average rate of change, really, we are finding the slope of the line that passes between those points. And if you zoom into this part of the function here, and you zoom into this line segment between those 2 points, they're very similar. Basically, what we're saying is that the average rate of change, the average slope of this curve, which is not a straight line, over that interval, is this slope. That's the average slope over that interval of this point. And the idea is that if we looked at a different interval, we would get a different answer. And really the idea is that if we can look over a small enough interval, we'll get the most accurate representation of the slope at that point. So this interval went from 2 to 2.5. It was a span of 0.5. It was an interval of 0.5. And you can tell visually that those look quite similar. But if I looked at, let's say, a different interval, like suppose I wanted to find the average rate of change over the interval 1 to 2. So that is a larger interval from 1 to 2. That's an interval of 1. So I would go through the same steps. I would plug in an x of 1 and then an x of 2 and find those 2 points. If you want to try it and see if you can find the average rate of change, you should pause now and give it a try. I'll show you the answers that I calculated in advance. So g of 1 is 1. G of 2 we calculated previously, it was -3. And when I plug in and calculate the slope, it's -4. And visually, that looks like this, and you can see visually that there's more of a gap between that line and the curve. They don't approximate each other quite as well. The larger an interval I pick, the less accurate the slope is going to be. And the smaller interval I pick, the closer it will represent the actual function's behavior at that point. The idea is that if we can take a small enough interval, infinitesimally small, then we can get the most accurate representation of the rate at which that function is changing at a given point. And that is going to be in a subsequent video lesson on the instantaneous rate of change. Thanks for watching.